And then you guys will have one of the world's strongest deep research workflows that get mapped into an operating system that you can sell to your clients at scale. What's going on, guys? My name is Kev. I just built the ultimate research agent that uses the Perplexity deep research model. And by the end of this video, you guys are going to have the exact same system that you're seeing here. Now, this ultimate deep research system scrapes and analyzes my competitors across YouTube, TikTok, and Twitter, which is long form videos, short form videos, and Twitter posts or written form. This agent works every single day. And once it finishes its work, it then gets stored in the operating system so we can display what's happening and all the data sourced in one very easy spot for our clients. And so if we click on the YouTube competitor agent, we can see all of the different competitors and their different videos that have been uploaded recently. And this is going to save me hours every single day identifying the best content and what my competitors are doing. And we have that working across 3 platforms. Now, this deep research agent can work for any type of research task. The agents can do crypto searches, stock searches, trending news, trending viral content. And so the beautiful thing about this agent, guys, is that you can rewire it for any business model on the planet. And then you can add it to your operating system. And this is exactly how I'm scaling my AI agency to a multi-million-dollar business, because we aren't just building AI agents, we are transforming the experience for our clients in a way that they've never, ever seen before. So without further ado, guys, I'm going to show you the exact breakdown, and then we're going to build this baby from scratch. So before I actually run the demo, I just want to explain exactly how everything works. So each one of these HTTPS nodes are predefined instructions on how to actually run the scrape. And so in the description of this Perplexity AI model, we said that you are a YouTube competitor scraping agent. Your goal is to scrape the YouTube competitors and then summarize the videos to the best of your ability. Then we also gave it today's date so that it understands what day it is and which content we actually want to source, which is the most recently created content. Then when we actually make the API call, we can actually add our competitors right here. And I just tossed in a few examples of my AI competitors. And then the system runs every single day. And once the Gemini chat model gets the response back from these agents, it actually makes the response look better. So I'm going to quickly run the workflow and explain everything that's happening, and then we're going to build it from scratch. So the Gemini model figures out its first destination, and that is the YouTube competitor scrape. Now, the deep research model on Perplexity is one of the strongest models for real-time internet research, because the way that the Perplexity AI company has created their AI model was internet first. So they were always using the internet for the AI agents to create their responses. And now with their deep research model, this thing can literally get you any type of data that you want across the internet. And that's why we separated each API call into each social platform so that these endpoints can have an exact destination that they need to go. And the YouTube competitor agent just finished up, and it actually went to the Gemini model, because now this model is going to grab that response and restructure it in a way that is best suited for it to be inserted into the database, which is our operating system. And so all of the other AI agency or AI automation people that are creating content on YouTube, they just show you the agent workflow, which is not valuable, but it actually needs to be stored in a centralized location like our operating system, so that our clients don't have to look all over the place to see the results of all of their different AI agents. All right, so now it inserted the data into the YouTube database, and we can see that there was 3 items that came along with it. So now the agent is going to probably hop over to the TikTok competitor deep research, which it did. And while it's doing that, we can open up what it actually stored in the YouTube comp. And we can see that it's giving basic summaries of the most recently uploaded video from my direct AI competitors. And so this is really, really powerful. But now, guys, in the operating system for our clients across the entire network, they're going to be able to see the exact specialized responses from these deep research agents in a very simple way. And so they just have to click on one of these cards and it'll give them that breakdown. So if I were to click on the TikTok competitor agent card, it literally shows me every single video that that deep research just scraped. And it gets better because we can also watch the actual videos that were stored. We can see that the video loaded and now I can review it. So essentially what we have created is an entire done for you algorithm that shows our users every single viral piece of content that our competitors have created across the 3 main types of social media content: long form, short form, and written content. And so even though this agent's going to continue working, you and I now are going to build this from scratch. And if you want to grab this entire blueprint and all of my other blueprints and my code bases that actually build the operating systems, then you can join the No Code Academy for all of that. But now let's just dive into a brand new build. So I'm going to now treat this as if I am a beginner on n8n building this exact same workflow with you guys. So the first thing we want to do is head into the n8n dashboard and open up a new instance. And so we're going to click Create Workflow, and we're going to name this the Perplexity Deep Research. Now, in this use case, guys, we're going to change things up. Instead of doing research about my competitors, let's do research about my investments. So I do a lot of investing into crypto, and I want to know about my favorite coins and what's happening every single day. And so that's what our deep research agents are going to do in this workflow. They're going to check for Bitcoin, Ethereum, Solana, and any other coins that would be relevant. We'll just start with those three for the time being. And the goal of this agent will be to find the most relevant news from these three cryptos. So the first thing that we want to do, guys, is actually have this run on a trigger. And this trigger is going to run on a schedule because we never actually want to touch this AI model. We just want to see the results in our operating system. So this thing's just going to work in the background 24/7, just how like the deep research model that we have here. And so now that we have the scheduled trigger set up, we want to add our AI agent. So we're going to click AI agent on the right-hand side, and we're just going to open that baby up. Now, the AI model that we're going to use for the AI agent is going to be Google Gemini Flash 2.5. Now, the reason why we want to use Flash 2.5, first of all, is because it's completely free. But second of all, the Flash 2.5 model can take up to 1 million tokens. And since this thing's going to be getting data from 3 different deep research models, we need all of that input availability to actually process all of that information. So that's the first thing we're going to do. Now, the next thing we're going to do, guys, is add a little sticky note. Now, this sticky note is going to be where the Perplexity AI agents will be. And we're just going to open up that sticky note, and we're going to add some nodes to it. Now, the Perplexity node for people in America have it already built in. So you could just write Perplexity and grab your node. Out here in Canada, we don't have that right now. So we're just going to make the same request through the HTTP tool. So we're going to open up the HTTP tool, and now we have to actually define all of these different parameters for the API call to actually work. So the first thing in the description is what we're actually going to tell it. And so let's say that this is the Bitcoin Deep Research Agent. So we're going to give it that description. And then we're going to click out, and we're just going to put that here. Now, the next tool we're going to grab is called date and time. Now, what date and time allows us to do is manipulate different times. And in this case, we just want to get the current time so we can map this information to our AI agents so they know exactly what day it is. And then that will help them actually source the correct information. So we're just going to click out. We're going to move that over to the Gemini model. And now we actually need to set up our HTTP request with Perplexity. So the first thing we have to do is open up the Perplexity docs. When you guys are in the Perplexity docs, the first thing you need to do is go and grab your API key. Once you do that, save it somewhere safe. And then we're actually going to head over to the Perplexity API reference. So I'm just going to click on the API reference, open that baby up. And now we can see all of the different request structures that we actually need to instruct that HTTP model to make the API call. So the first call that we do is called a chat completion. And so in the CURL breakdown of the different coding languages, we know that make.com and n8n use the CURL type of coding language. So we can copy this post request and we can head back to our workflow. And we can open up this HTTP request step and we can just paste in this in the body. Right here on the screen, if we see send body, we can click that. And the body content type will be JSON. The specify body will be using JSON. And then we're just going to paste in that schema that we just found. So now we want to figure out which AI model we want to use. So back on the Perplexity API reference, we can go to the tab that says models and open that baby up. And now we can see we have access to 3 different AI models through their API. And in this use case, guys, we're going to be using Sonar Deep Research. So we just need to copy the name of that AI model, and then we'll head back to the build out of the HTTP request. And we can see here in the model explanation, we need to add in the Sonar Deep Research so it knows to use that specific AI model. Then the next thing we do, guys, is add a system prompt and then a user prompt. So the system prompt is a static message that always gets sent to the agent before it reads the user prompt. And so in this example, we're going to write, you are a research agent. In the user prompt, we can now change this as well. So we can say, grab the 5 most relevant news sources. So now let's add in the URL. So let's head back to the Perplexity model. Let's go to the API reference, and we can see in the URL that the HTTP request is /chat/completions. So we're going to copy that. We're going to head back to the HTTP, and we're going to paste that in. The next thing we have to do is change the method from get to post, because the request on Perplexity says that this is a post request. Then the next thing we need to do is start adding in the authorizations. So the authorization that we need here is a authorization header with a bearer API token field. So if we head back to our build and we go into the headers and we turn on the send headers, we can now add in those parameters. So the name is authorization and the value is bearer and then your API key. So I'm going to head back to Perplexity and I'm going to go and grab my API key and then I'm going to insert it. All right. So just like that, boom, we're going to insert it. And now this agent looks basically ready to go. So we're going to click out. We're now going to rename this agent to Bitcoin Deep Research. Now that we have this guy already set up, we can actually duplicate it to save us a bunch of time in setting up all the different HTTP nodes. So we're going to click copy, paste, and now we have 3 Perplexity agents, but they all say the same thing. So we just want to rename what they do. So the first one, we're going to change from Bitcoin to Solana. I'm going to rename that. And the second one, we're going to rename from Bitcoin to Ethereum. Now we can open up these nodes and we can just change the wording. So instead of you are a Bitcoin deep research, you are a Solana crypto deep research agent. And in the body, in the system prompt, we're going to change it from you are a research agent for the Bitcoin cryptocurrency to Solana. And same thing in the user prompt, we're going to add Solana. And we're going to click out and click save. Now we're going to do the exact same thing with the Ethereum. So we're going to go into the description and we're going to change Bitcoin to Ethereum. Then in the body, we're going to do the same thing. So the system and the user prompt. Awesome. So now guys, we're just going to click save and we're just going to run one of the agents. So we're going to now deactivate Solana agent and we're going to deactivate the Ethereum agent, and we're just going to run this automation one time just to see how the Bitcoin deep research is working. Now that the Perplexity agents are set up, we just need to instruct our AI agent about how to actually run things. So we're going to click the AI agent step and we have to add in the user message. We can also add in a system message at the AI agent level, but in this workflow, we don't really need it. We just need the user prompt. So we're going to say you are the ultimate crypto deep research agent. And then we're going to say, when you get the response from the research agents, I want you to reformat these responses for a database store. And then we're going to click out. And then we're going to click save. And now we're going to test out the workflow. So what should happen is that the agent thinks about everything that we told it, and then it goes and triggers off the Bitcoin deep research. So now we just have to wait until we get that response. So the Bitcoin deep research just finished up and we just need to wait for the agent to finish now. But the reason why we wanted the Bitcoin deep research agent to actually, conduct its workflow is because we need to see the response from this agent, because the response gives us something called a schema. And this schema is what we can use to actually store all of this information properly inside of the database. So what I'm going to do is I'm not going to grab this schema. I'm going to grab the schema from the Gemini model that grabbed the Bitcoin deep research response and then reformatted it. So this is the reformatted version of the response. And so what I'm going to do, guys, is I'm going to now copy the entire JSON response from the AI agent, because we now need to build out a table in your operating system to actually store this information. So I'm going to open up Replit, and you guys can use any no-code tool that you want. If you're a part of this, if you've been part of this channel, there's a reason why I'm a big fan of Replit. It has a bunch of different integrations that is just way ahead of all the competitors. But basically, we could just start an app here. So we can just say, I am building the ultimate crypto research agent, and I need you to build out the application so that we can display the research that was conducted, and we can improve that prompt, and then we can send that in. So you guys are also going to get the actual code base of this. It's going to be a public repo that you guys can just fork and see how this agent can actually store the data in this application for your guys' workflows as well. And that is something that genuinely no other AI no code builder on the internet is giving to you guys. So I hope you guys appreciate that. But we're just going to click approve plan. And now we're going to let the agent cook. We're going to head back to the Perplexity agent and we're going to reactivate the Solana and the Ethereum. And so we have to now instruct the AI agent on which steps it needs to do first. And so while that's happening, guys, and while the app is being built on Replit, we can now put these things side by side. So we're going to open this up in a side tab here, and then we're going to open up Replit on the right-hand side. And the reason why we're doing this is because we are waiting for the Replit app to actually build us a database. So we're going to open up a database tab in the right-hand side, because what we need from this database are all the API keys for us to connect to this AI agent. And so in the meantime, we can start working on those different nodes. And so we're going to add a sticky note. And this sticky note is going to be called operator system storage. And we're going to click on a tool and we're going to search for Postgres. And then we're going to go grab that Postgres tool. And the operation that we're going to be doing here is an insert operation, because we're letting the agent insert the deep research data into our operating system. And so that is what the operation step is. Now, the next thing we have to do is add our actual credentials to this agent. And so what we're going to do is click create new credential. All right, so the agent just created the database. And so what we're going to do now is map all of these values to the n8n workflow. And so the first one is the host. So on the right-hand side, it's the PG host value that we want. So we're just going to copy that and paste it in. Then it's the database step. So we're going to go grab the PG database and paste it in. Next one is PG user. And then PG password. And then we can scroll down here, and where it says ignore SSL issues, we're going to turn that on and we're going to click save. So now this workflow has set up to this application. So now we just need to build out the different tables in the actual application, because right now we can see that the results is saying that there's no tables. So we just have to wait for the agent to finish up that step. And so now, guys, while the agent is working, we can now click out of the Postgres step and we can go and grab the response that was from the Bitcoin deep research. So we're going to go into the Gemini chat and we're just going to copy this entire response. And we're going to tell the agent to build out that table in the database. So we're going to say, can you please build out a table in the database called Bitcoin deep research? Build out the table schema with the following fields. And then we'll paste in the response that we just got from the Bitcoin deep research. And even though the agent's working, we're just going to send that in. And so now that we have connected our Postgres database, we can now duplicate this 3 times to save us time as well. So we're going to go copy, paste. And now we have the 3 separate tables that should be storing the 3 different deep research results. So we're just going to make those connections. And now we can rename these. So the first one we could rename as Bitcoin data store, and then Solana data store, and then Ethereum. And so now in our Replit app, we can open up the database tab just to see if there's any tables that have been built out yet. It already built out the Bitcoin deep research table. We can go back and click on the Bitcoin data store node here. And we can open it up, and now we can actually choose that table that was just built. So we're going to go now click Bitcoin deep research, and we can now map in these different values. And so the beautiful thing about n8n is that we can let our AI agent actually decide what values to store in each row in the database. And we can do that by clicking the let model define this parameter button. And so we're going to do that with every single field that can be inserted into this database, because the Gemini model is going to get the response back from the Perplexity models, and it's going to actually make the response properly store in the Bitcoin data store step. Now, before we move forward, guys, we need to make sure that there's no constraints on the table that we need to store the data on. And so if we open up Replit and we'll go full screen here, and we click on this 3 stack to look at the structure, we can see that there is a constraint. And this constraint could actually give us some headaches. And so we actually just want to completely remove any restraints from a table that is storing data from our n8n workflows. And so now that that's done, we can click out and we can actually test out this entire workflow. So I'm going to deactivate Solana and Deep Research one more time, and I'm going to deactivate the data stores for Solana and Ethereum, and we're going to now run it. And so what should happen theoretically is the Bitcoin Deep Research finishes its step, it gets passed to the Google Gemini model, and then it gets stored in the database. And then we can work on actually displaying all that information for our users in the future. So we're just going to click execute workflow and we'll see what happens. All right, so the Bitcoin Deep Research step is firing off. If you made it this far, please just smash the like button like it's someone you hate. All right, just fucking smash it. All right, so Bitcoin Deep Research just finished. Now the Google Gemini model needs to restructure all of that data, and hopefully it properly stores it in the Bitcoin data store. So we really want to see what happens right now. All right, there we go. And we got an error. So we're going to stop the workflow and we're going to look at what that error was. And so we could see here that the invalid input for key feature strengths is the issue. So what we can do is we can find that field that is giving us that issue, which is right here, the key feature strengths, and we can actually delete it from the entire schema. And so what we're going to do is we'll go back to half screen and we'll open up replit now, and we'll go inside of the database and we'll go find that row. So the row that we want to get rid of is that key feature strengths, and we're just going to go drop selected and click drop. Okay, great. So now we can go back to the n8n workflow and we can test that again. So we're just going to click out, we're going to click save, and we're going to run this one more time. And all right, here we go. Now, while that's happening, on the right-hand side, I told the agent to build out the exact same table schemas for both the Ethereum and Solana cryptocurrencies. And so the agent has actually gone ahead and done that. And so if we go inside of the database now, we can see that there's brand new tables with the Ethereum Deep Research and the Solana Deep Research. So that's all looking really, really good. So once we can get the Bitcoin Deep Research to store data in the Bitcoin data store, then we can try all three at the same time. And then you guys will have one of the world's strongest deep research workflows that get mapped into an operating system that you can sell to your clients at scale. And the way that we sell this offer to our clients is it's just one tool out of all of the different tools that we have available to offer our clients. And so people that are creating content, we can have a deep research workflow that looks for all of their competitors. If someone's running an e-commerce brand, we can have another workflow that looks at the product competitors. If someone's running ads, we could do the same thing. If someone's doing stocks, crypto, whatever, all of these workflows definitely work with the exact same blueprints that you guys are going to have in the academy. All right, so Bitcoin Deep Research finished off. Now this is the moment of truth. Is it able to store it in the database this time? All right, there we go. So the agent just passed 5 items, and we can see that right here in this value that says 5 items on the screen. And we can head over to the database on the right hand side, and we can head over to the Bitcoin Deep Research, and now we can see all of the different URLs. So we got a crypto slate, crypto Cointelegraph, CoinDesk, Bitcoin.com, and Bitcoin Magazine with the entire breakdown for the month of July, and then also the year that the company or the resource that we sourced from was founded, and how many monthly visitors are actually visiting these different pages. So the detail on this is pretty ridiculous, guys. And then we can map all of this information to the front end on our app. So on the Bitcoin research page, you can actually map all of that research data. But we're not worried about that. You guys are going to be able to handle that on your own. What we're worried about is getting the entire system working. And so now we're going to open up and activate the Solana and Ethereum Deep Research, and we're going to open up the Solana and Ethereum tables in the database. So I'm just going to head into the operating system storage, and I'm going to activate both of these workflows, and then we're going to open up the Solana data store, and we're going to click on the list of the different tables that we have access to, and we're going to click the Solana Deep Research. For the Solana Deep Research, I'm just going to again let the model define every single one of these parameters. We're then going to go into the Ethereum data store, and we're going to grab the Ethereum database table, deep research table, boom. And then we're going to do the exact same thing here and map all of the relevant values using the model defining the parameter button. And here we go. So we now have an end-to-end research agent that is searching for all 3 of my favorite cryptocurrencies and what I'm investing in. And it's grabbing data from the most recent time. And it's doing that with the date and time step. And so what we can do to actually make these prompts better now is we can map in the date and time information. And so if we go into the description here, we can say at the bottom, it says this is the time of the day. We can go and find this today value, and we could just map it in. So we're just going to paste that in there, and we're going to do that for all of the research agents. So we're going to go into Solana, and we're going to map in the readable date, and then we're going to go to the Ethereum, and we're going to map in the readable date as well. Cool. So we're going to click save. And now guys, we are going to test the full workflow. So let's click execute workflow, and based off of the instructions that we gave it, it's going to go to Bitcoin research first. Great. Now it's back to the Gemini model, and it should then store it in the Bitcoin data store. All right, there we go. It's now inserting the database. It's saying it has a total of 5 items. That's awesome. Went back to the Gemini and then immediately to the Solana deep research. There we go, getting stored in the Solana database. Awesome. Now it's jumping back to Gemini, jumping back to Ethereum. Looks like we've got the full end-to-end workflow cooking. So while that's happening, we can check the Solana database to see if we got anything in that table. And there we go. So we got a source URL. We got a little description here saying Solana has emerged as a leading blockchain platform in 2025, blah, 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 blah. Great stuff there. And so let's see what we get for the Ethereum. And it's storing as we speak. There we go. Let's see if the actual agent finishes up. And it's completely done, guys. So we now have a complete end-to-end research agent that is being stored in an operating system. And what this allows us to do is then clone that exact blueprint workflow every single time that a client wants that in their own operating system. And this is just one of the many systems that we can integrate for any one of our clients. So I hope this helped, guys, and I'll see you in the next one. And I'm really looking forward to see what you guys can build with your own research agents.